certain characteristics and behavior. From a practical standpoint, however, electricity is a very valuable and useful tool for performing very simple to very complex tasks. In this program on direct current circuit elements, you'll be introduced to some of the electrical circuit components with which you, as an aviation maintenance technician, will be working. All complete electrical circuits must have three basic elements: a source of electrical energy, a load to use the energy, and a conductor to connect the source and the load. The source of electrical energy in most aircraft electrical systems is the battery. The battery converts chemical energy to electrical energy. The source may also be a generator or any other device which converts one form of energy into electrical energy. The load is anything which uses electrical energy, such as lights, communications and navigation equipment, and motors for operating various aircraft systems. The conductors used in most aircraft are copper or aluminum wire, which provide a path for electrons to flow from the source to the load and back to the source. A single-wire electrical system used in most aircraft uses the aircraft structure as a return path between the load and the source. Using the airframe as a return path requires a low resistance path between the different parts of the structure. The single wire eliminates the need to run a separate wire as a return path, thus saving weight. A minimum amount of resistance is an important factor in selecting a conductor. The physical properties and the size of a conductor have a direct bearing on its resistance. Resistivity is a physical property of a conductor that helps determine its resistance. Resistivity may be thought of as being similar to the hardness of a rock or the stiffness of a spring. Copper wire is the most widely used electrical conductor in aircraft. Copper has a lower resistivity than aluminum and therefore has a lower resistance. However, where current requirements are high, aluminum wire is sometimes used. Although a large conductor is required because of the high resistivity of aluminum, the weight of aluminum is much less than that of copper. There are three major factors affecting the resistance of a conductor: its length, its cross-sectional area, and its temperature. In general, resistance increases as length increases and decreases as cross-sectional area increases. Resistance will also increase as temperature increases, although this change is negligible in the temperature ranges encountered under most flight conditions. If the length of a wire is doubled, its resistance will double. If cross-sectional area is doubled, resistance will be cut in half. Aircraft wire is measured by the American wire gauge standards. Each wire gauge represents a certain cross-sectional area in circular mills. In this chart, the largest number represents the smallest wire gauge. The 20-gauge wire is the smallest on the chart. The 4/0 wire is very large wire used for carrying high current loads. It would be more than a little inconvenient to have to connect or disconnect a wire every time we wanted to turn a piece of electrical equipment on or off. For this reason, we use switches to open and close electrical circuits. A closed circuit is one that is complete and operating without any faults. The most common faults in aircraft circuits are open circuits and short circuits. An open circuit is one that has been interrupted either by a switch or a break in the circuit or one of its components. A short circuit is one in which a current-carrying conductor contacts another conductor, bypassing the load and creating a shortened path back to the source. Short circuits are hazardous in that they may carry large amounts of current which may exceed the current carrying capacity of the wire. Short circuits often overheat electrical wiring and cause electrical fires. Current may be controlled in a circuit by the use of a switch. A switch that opens or closes only one circuit and has only two connections is called a single pole, single throw, or SPST switch. This is a simple on-off type switch, such as that used for controlling aircraft position lights. A switch with three connections and either two or three positions is a single pole, double throw, or SPDT switch. This switch may be used to operate the same circuit in two different positions and is commonly found in the circuit to raise and lower aircraft landing gear. It may or may not have a neutral position. A double pole, single throw, or DPST switch may be used to operate two different circuits. It has four connections and two positions and is often found in circuits that turn the battery and generator on and off. A double pole, double throw, or DPDT switch is used to control two different circuits in two different positions. It may sometimes be found in the emergency power system, allowing the pilot to switch from one source of power to an alternate source. A wafer switch or multiple contact switch is operated by rotating a contact to any one of several other contacts to select the desired circuit. The multiple contact switch is used in selecting radio channels and for selecting readings on some multiple reading instruments. Precision switches are designed to operate when moved to a precise position. They normally require very little motion to open or close a circuit and are used as limit switches to stop the motion of retractable landing gear at an exact position, either up or down. Micro switches control the motor which moves the landing gear and are operated by a tang located on the gear itself. So far, we've dealt with switches that are mechanically operated, either by hand or by the motion of some system in the aircraft. Some switches are operated electrically and are divided into two categories: relays and solenoids. A relay is an electrically operated switch with a fixed iron core or no core at all. It is simply a coil of wire that, when operated, creates a magnetic field which pulls on a set of contacts to either open or close a circuit or several circuits. A solenoid is an electrically operated switch which uses a movable iron core to operate a set of contacts. Solenoids and relays use a small amount of current to control circuits carrying a large amount of current. The starter motor on an aircraft requires a large amount of electrical current. By using a relay or solenoid, only the circuit from the battery to the starter need be of heavy gauge wire. The circuit from the starter switch in the cockpit to the relay near the starter may be much smaller, since the only electrical load in this circuit is a small electromagnet. Electrical circuits must be protected from too much current flow to prevent overloading the wiring and burning it out. Not only is an overload damaging to the wiring, but it is also a fire hazard. Circuit protective devices are designed to open the circuit and interrupt the current flow if the current flow exceeds specified limits. A fuse is made of a metal alloy strip with a low melting point, usually enclosed in a glass case with contacts on the ends. As current flows, a certain amount of heat is always generated. As long as it does not exceed limits, the circuit will continue to operate normally. But if too much current flows, as in a short circuit, much more heat is generated, causing the fusible link inside the case to melt. With the circuit opened, no more current may flow. The slow-blow type fuse is designed to allow momentary surges of high current, but will open the circuit if an overload is sustained for too long a period of time. The slow-blow type fuse has its fusible link connected to a spring. When sustained high current softens the link, the spring tension pulls it apart. While fuses must be replaced once they've done their job, circuit breakers may be reused. Circuit breakers are simply switches that open a circuit when too much current flows. Circuit breakers may be designed to sense current flow directly or may operate according to the amount of heat generated by current flow. Most circuit breakers are designed to permit momentary overloads without interrupting the circuit. However, if the overload is sustained for a period of time, the circuit breaker will open the circuit and must be reset. If a fault caused the overload, the circuit breaker will normally break the circuit within a few seconds after it's reset. Aircraft circuit breakers are often of the trip-free type that will open a circuit if there is a fault, regardless of the position of the operating control. A trip-free circuit breaker cannot be reset until the fault is corrected. Current flow may be regulated by varying the voltage in a circuit. This may be accomplished by the use of resistors. Power is dissipated through a resistor in the form of heat. Resistors may be either fixed or variable. A fixed resistor is usually composed of carbon and an insulating material. The percentage of the two materials in the mixture determines the resistance value of the resistor. This resistance value is usually color-coded in the form of bands on the body of the resistor. The standard axial lead resistor has its leads extending directly from the ends. Each colored band conforms to a standard code shown in this chart. The color band nearest the end of the resistor represents the first significant number of the resistance value. The violet band on this resistor represents the number 7. The second band represents the next significant number. Green represents the number 5. The third band represents the multiplier, or the number by which the first two numbers are multiplied. Here, black indicates there is no multiplier, so our resistance value is 75 ohms. The fourth band represents the tolerance or deviation that the resistor will permit on either side of the actual resistance value. Here, the gold band indicates a tolerance of plus or minus 5%. The tolerance of this resistor is between 71.25 ohms and 78.75 ohms. A silver band would indicate a tolerance of plus or minus 10%, while no fourth band indicates a 20% tolerance on either side of the actual resistance value. These composition type resistors will usually dissipate between 1/8 watt and 2 watts of power. Special wire-wound resistors are used to dissipate larger amounts of power. Some wire-wound resistors are equipped with taps or connections for different resistances, and some are equipped with movable taps to vary the resistance desired. Another form of variable resistor is the rheostat. A rheostat has two terminals and varies the amount of voltage in a circuit. A potentiometer is similar to a rheostat, except that it has 3 terminals and may be used as a voltage divider. You've seen what goes into the basic electrical circuit. Understanding the elements of direct current circuits is a prerequisite for further study in electricity.